Hello, my name is Marcelo Soares and I'm here to present a quick presentation about vMware snapshots, how they work and how we can troubleshoot this kind of technology, and some tips and tricks on have it working better. Here I will show first how to take a snapshot and what are the pros and cons on having snapshots, and what you can, what you cannot do. And then before that I will just show how to troubleshoot, the simple troubleshooting of snapshots, and how you can avoid problems with this technology. So snapshots are like photos of virtual machines in a determinate time, meaning that you have your virtual machine, you install the operational system, install software, and for example you want to perform a test of a new software installation, but you don't know if this will break your virtual machine or break your operational system or not. So before doing anything that may harm the virtual machine, you can take a snapshot, so you have like a safe photo of the state of the virtual machine in a determinate time. So when you taking the snapshot, you have this point in time photo, and then you can perform anything you want inside the virtual machine. You can erase files, install applications, and try to perform operations that could cause any damage to the virtual machine. And if anything goes wrong, you can go back to that point of time that you took the snapshot, and the virtual machine simply goes start working as nothing happens. Or if you perform your test, you saw that the informations are correct and nothing wrong happened, you can keep that state and erase the snapshots, meaning that you can discard it and you don't need it anymore, and you want to go on with your actual state of the virtual machine. Okay. So what we can do with the snapshots? Okay, the snapshots can be performed with VMs powered on or off. Okay, the snapshots can be quiesced. What this means? Quiesced snapshots are crash consistent snapshots, because when you take a snapshot of a virtual machine, you are freezing the state of the disk of this virtual machine, meaning that when you go back to this snapshot, and for example you go back and power on the virtual machine, it's like that the virtual machine stopped in a point of time and it was powered off, and then you power it on again. If we can see, we can think about just have a virtual machine running, power it off and power it on again. You can have some damage on the file system of the virtual machine, the NTFS of the X3 on Linux or Riser FS. So the snapshots can have this kind of problem. Doing a quiesced snapshot will make that the operational system flush everything to disk before taking the snapshot. So it's a crash consistent snapshot, and it will look like a shutdown of the virtual machine. And when the virtual machine powered on again, it will simply power on, and the chances that you have file system problems is almost zero. So quiescent snapshots are most used for backups. This is another very common use of snapshots. You take a snapshot of a virtual machine with a backup tool. The backup tool does this automatically for you, and then a backup of that snapshot is taken and then stored on tape or on disk, on everything else. And this kind of functionality is used for so we can have a crash consistent snapshot. Okay. Snapshots can be performed in RDMs also. So if you have a virtual machine with direct access to a disk with route device mapping, you will be able to take a snapshot of a virtual machine. Okay, it's a wrong assumption that the thing that the RDMs will not be supported with snapshots. Okay, what we cannot do, this we can. What we cannot do on snapshots, we cannot take snapshots of virtual machines that participate in some sort of clustering software like Microsoft Cluster or Oracle RAC. Okay, if we have two virtual machines sharing the same disk, the snapshot of both virtual machines will not work. VMware, the vSphere is not capable of taking snapshots of this kind of scenario. Also, if you have virtual machines using fault tolerance, FT, this also will not work with snapshots. So vSphere still is not able to take snapshots of fault tolerance enabled virtual machines. Okay. So how can we take snapshots of virtual machines? It's very simple. First of all, when you are on the vSphere administration console, on the vSphere client, for example, or the web client, or the vSphere client, the Windows installed, you can simply right-click a virtual machine, even if it's powered on or powered off, and then you can select snapshot and take snapshots. This simple operation can be performed, and it will be it should be very fast. And then you have your snapshot taken from your virtual machine. Okay, so after that, you can simply go to right click again on the virtual machine, go to snapshot, and you have an option enabled, name it, and manage snapshots, where you can see the snapshots that you have and go back and forward. And also you can delete all the snapshots, delete a specific snapshot, or delete all the snapshots, meaning that the delete all operation is the state when you say, okay, I performed all the changes to my virtual machine, everything is running okay, and I want to keep all the changes and discard the snapshot. So the delete all option does that. If you want to go back to a point in time that you took a snapshot and want to discard all the changes that you made, also discarding the snapshot obviously, you right click on the virtual machine, go to snapshot, and go and say that you want to revert to snapshot. So reverting to a snapshot will make you go back in time to a certain point where you took the snapshot. Okay, so I am assuming here that you have knowledge about the virtual machine file naming and how to browse data stores, where the virtual machines are stored. So I will show how the file architecture on the snapshot works. Okay, so we will take an example. We have VM1. So this VM1 have the, like, simplifying thing. VM1 have the virtual machine file vm1.vmx. This is the virtual machine configuration file, where all the information of memory, processors, and how many disks and how many network adapters the virtual machine have. And then I have a file named vm1.vmdk. Okay, and this file points to a file name vm1 flat.vmdk. So we have the VMX pointing to this file. This file is just a simple header. It's a very small, like 1K, 2K, and we have inside this file information about the size of the disk and the type of the disk, if it's zeroed, if it's not zeroed, if it's an RDM or anything else. And then this file points to our flat file. The flat file is it's the file that effectively have the disk itself. So obviously if we don't have RDMs. If you have RDMs, this file will only point to a LUN, to a physical LAN, and we will not have this flat file. But having simple vmdk files, the normal ones, stored inside a VMFS or inside an NFS, we'll have this structure. So the flat file in an 8 gig disk will have 8 gig. Okay, obviously with thick provision. If you use thin provision, this file will start small, like 1 meg, and will grow with the time until it reaches 8 gig. Okay, you can have disks as bigger as you want. Obviously in vSphere 4 you have to have in consideration the block size. So you can have 256 gig or 512 or 1 gig or 2 gig, 1 tera or 2 tera disks. Okay. But now with vSphere 5 and VMFS 5, you don't need to worry about it. You can have 64 terabytes VMDK files for your virtual machines, as long as you have space in your LAN. Okay, so this is the basic file architecture for a virtual machine. When you take a snapshot, what happens? The VMX file, the virtual machine configuration file, it's not pointed anymore to the VMDK, so it points to a file name VM1 -00001.vmdk. Okay, this file we call the snapshot. This is a file descriptor like the VM1.vmdk. You don't have information on what time was the snapshot taken and who is the parent, the original disk of the virtual machine. And this file inside points to another file named VM1 00001 delta.vmdk. Okay, this delta file is what we call a read-to file. So this delta file will store all the information that should be changed inside this flat file, and this VMDK will point to his parent. So first of all, the VM1 was pointing to VM1.vmdk. When you took the snapshot, it pointed now to this file, to the 0001.vmdk, and this file points to his delta, that is the changelog, and the VM and to its parent. So it says all the changes that should be done to this file, to this disk, because this represents one disk. Okay. All the changes that should be made to this disk will be stored here. Okay, but the changes mean everything. So if you change, like you copy a 1 meg file to the virtual machine, to this disk that's being represented here, this file will increase 1 meg. It's not exactly like that, but we can simplify and think about that. So when you copy a 1 meg file to this disk, this file will increase 1 meg. And when you erase a 1 meg file or a 2 meg file, this will not decrease its size. It will increase because it's a change log. So here is being stored. Okay, now 1 meg of the bits of this flat file were changed to something else. And when you erase a file, it stores, okay, 1 meg of bits on this flat changed to something else, and this file only increase in size, never decrease. Okay, this can take us to a problem. If you take a snapshot and forget about it, like take a snapshot, perform your test, and you forgot to go back or to erase the snapshot, you can have a problem where you will fulfill your free space on a data store or an FS or a VMFS. This is the worst case ever that you can have, because if you have not enough free space on a VMFS, that data store for a virtual machine, the virtual machine will power off, and then you will not be able to power on the virtual machine again, because you will receive an error saying that there is not enough space on the data store to power on the virtual machine, and if it's a production virtual machine, you can be in serious problem. So to avoid this kind of thing, we can use many tools on the vSphere side that mainly we can use the alarms. Okay, so you can, I suggest here that you use two alarms. The first one is the snapshot size. What's this alarm? You can set this alarm to all your virtual machines just with one configuration on the top of your virtual center, saying that when a delta file or a snapshot file, as it's called on the vSphere, reaches like a definite amount of gigabytes, you will receive this alarm. So you can say when a delta file reaches 20 gigs, I want to receive an alarm, a warning saying, oh, virtual machine VM1 reached 20 gigs of snapshot file utilization. And when I have 40 gigs of snapshot file size, I want to receive a red alarm saying that it's being dangerous for you to keep this snapshot on the virtual machine. So I will give you a red alarm. Okay, you can set the triggers on the alarm as to whatever you want. So you can receive this kind of alarm. You can set an email to receive an email about it. So it's very useful to have this kind of thing. The other thing, obviously, that you already have by default on vSphere is free space on data store. Okay, so when you start running low on free space in a specific data store, you will receive an alarm saying that oh, you have only 20% of free space on the data store, and when you have 5% only, you will receive a red alarm saying that you are very low on space on the data store. Okay, this kind of alarm may be useful, maybe not. For example, 20% in a 100 gig data store is 20 gigs, and 20% in a 2 terabyte data store is 400 gigs. So if you have 400 gigs free on data store, obviously you have still space to store a lot of snapshots or even a new virtual machine. So maybe you need to create specific alarms for big data stores and for small data stores, so you have a better understanding on what is happening. Okay. In the case that you have problems with snapshots like the one I said, when you have a snapshot that fulfill a data store and you cannot power on the virtual machine anymore, first thing, don't panic. Don't try to erase anything. If you erase any of the files that I was showing here, you will not be able to recover your virtual machine. In the better cases, you'll be able to recover the virtual machine on a past point of time, what may not be useful. For example, if you have a database server, having a database server in the state it was 1 week before that, it may not be useful. So the first thing you can use on vSphere 5, this is vSphere 5 only. You can use consolidate. So if you right click on the virtual machine snapshot, you have an option named consolidate. This will apply the delta file inside the flat file. So it's like a delete all operation on your snapshot. It will make your virtual machine to go to the state as it was before powering off. So this may be very useful and the faster way to have your virtual machine back, but this will need like 20% or 30% of the virtual machine disk's size free on the VMFS data store. So if you are running out of space, maybe this will not work on your environment. Okay, you can try to delete all, obviously, delete all. snapshots, you go right click on the virtual machine, snapshots, snapshot manager. Delete all operation will remove all the snapshots and maintain the actual the actual state of the virtual machine. So in this, we will erase all the Delta files and recover you back free space so you can power on the virtual machine. For this to work, you need a small amount of bytes free on the data store. This may not be the case, and this may not work if you have not enough free space on the data store where the virtual machine resides. Okay. What you can also do is to increase the data store size. Okay, this is the easiest way, I think. You just go there in your storage, increase the loan size where the VMFS resides, or increase the NFS share size, and then you have more space, and then you'll be able to power in your virtual machine and try to consolidate or delete all. And with the virtual machine powered on or not, I suggest you to not perform this operation with the virtual machine powered on, and keep the virtual machine power off a little more for a little amount of time more, and try to delete all and consolidate after increasing the size of the data store. Okay, you can also discard the snap. Okay, to do that, you just go. You can edit settings of the virtual machine, remove the disks, remove the appointment of the disks, and point to the non-snapshot disk. So you will point to the flat disks, and we will simply ignore the snapshots, and then the virtual machine will power on. But you have the virtual machine in a best state. This may not be useful for a database server or anything else because you lose all the changes you made since you took the snapshot. Okay, this may be dangerous, and once you do that, you will never be able to go back and use your snapshots again, because you changed the original disk, and then the vSphere will not be able to use the change log to apply the change to the original disk. Okay. The best way to try to recover everything is to clone the virtual machine. The clone will make a new virtual machine with all the snapshots applied and with no snapshots, but you will need to have enough free space to perform a clone operation. If you have a 500 gig virtual machine, you need a 500 gig free elsewhere, so you can clone the virtual machine. You can create a new LAN, you can use a LAN that you have enough free space, or you can try to clone the virtual machine using thin disks, meaning that you may not use all the 500 gigs, but there is no way to predict how much you will be using when you perform a clone operation. But this is the safer way, and you have a clone without snapshots. You can then power on the clone, check if everything is okay, and then discard the old virtual machine, freeing up space on your data store. Okay, so that's it for now. Thank you very much, and